Good morning all. Today we are going to discuss on how to calculate the centroid of some composite sections. So we will discuss composite sections made up of rectangle. So first we will see the centroid of a rectangular section. So the figure shows a rectangular section. So the figure is a two-dimensional figure which has only area. So the total area is concentrated at the geometric center. So centroid is the point where the whole area is concentrated. So in this module also we are dealing with only plane areas. For example, rectangle, semicircle, circle, triangle, etc. So all these figures have area. So we have to concentrate on the point where the whole area is concentrated. So for this rectangle, we assume the base width as B and the depth as equal to D. So based on the reference axis OX and OY. So these reference axes are taken, OX is taken along the bottom line and OY is along the extreme left of the figure. So based on this reference axis, the centroid is located at a distance B by 2. That is, the x coordinate of the centroid is B by 2 and the y coordinate of the centroid is D by 2. So x coordinate is measured from the OY axis and y coordinate is measured from the OX axis. So this you have to remember. For a rectangle, x coordinate is equal to B by 2 and y coordinate is equal to D by 2. So now the area of the rectangle, area is equal to base width into depth, that is equal to B into D. So now we will see figures made up of rectangle. So the first composite section is a T section which is made up of two rectangles. This is first rectangle and this is the second rectangle. Second figure is an I section which is made up of three rectangles. And in the third figure it is made up of three rectangles. This is the first rectangle, this is the second rectangle and this is the third rectangle. You have to divide the figure into rectangular shapes. And now this is an angle section which is made up of two rectangles. So we will start the calculation of centroid from this figure. So to calculate the centroid of an L section or an angle section, the first step is you have to draw the reference axis. So you have to draw extreme left line and mark it as OY axis. So which is used to measure the x coordinate of this composite section. And the bottom line is marked as OX axis. So these two are known as the axis of reference. So first of all, after getting the figure, you have to draw this reference axis. So this will carry marks. So if you don't mark this line, you will not get one mark. So now the next step is you have to divide this figure into two rectangles. So this is how I am dividing. This is the first rectangle and this is the second rectangle. So now we have already discussed in the class on how to calculate the centroid. So in order to calculate the centroid, we are using the principle of moment. So according to the principle of moment of the total area about an axis is equal to the moment of individual area about the same axis. So here we are going to use that principle, capital A, that is the area of total area of this composite section into x coordinate. That is capital A into x bar indicate the first moment of the total area. That is equal to the sum of the moment of the individual area. That is first area is assumed as A1 into x1 plus A2. That is area of the second figure, and the A2 x2 represent the moment of the second area about the axis. So here we are taking moment about the OY axis. So x bar represent the x coordinate of the centroid. Maybe the centroid is here for the composite section, and for the first rectangle centroid is assumed here, and for the second rectangle centroid is assumed in this position. So now we are taking moment of this total area about this OY axis. So now x coordinate is equal to A1 x1 plus A2 x2 divided by capital A. Similarly, y coordinate is calculated using the equation capital A into y bar is equal to A1 y1 plus A2 y2. So y bar is equal to A1 y1 plus A2 y2 divided by capital A. So here x1 is the distance of the centroid of the first rectangle from the OY axis. So this distance is taken as x1, and this distance is taken as x2, and x bar is this distance. Similarly, y bar is this distance, y1 is this distance, and y2 is this distance. You have to calculate all this value. So first we will write what is A1. This is the first rectangle. Area is equal to breadth into depth. A1 is equal to 12 into 200. And now A2. A2 is equal to second rectangle. The area is equal to this width. This is equal to, this total length is 150. So 150 minus 12. 150 minus 12. That is 138. 138. So 138 into 12. So I can assume all the dimensions in millimeter. So here the unit is millimeter square. So next step is you have to calculate the value for x1. So x1 is measured from the reference axis OY. So from this axis to the centroid of the first rectangle. So this width is equal to 12. So this length is equal to half of 12. So x1 is equal to 12 by 2. That is equal to 6. And y1 is this distance. That is distance from this reference axis to the centroid. So this length is equal to, total depth is 200 by 2. So y1 is equal to 200 by 2. That is equal to 100, and unit is millimeter. So now the second rectangle. Second rectangle is this one. So you have to place. So here you have to mark the distance of this centroid from this reference axis. So here the centroid is located at a distance half of this 138. That is, this length is equal to 138 by 2. Plus you have to add this length. So x2 is equal to, this length is 12 plus 138 by 2. So 12 plus 69. That is equal to 81 millimeter. So now y2. So here this length is equal to That is, distance of the centroid from this point is equal to d by 2. You have to measure the distance of the centroid from this reference axis. So this length you have to calculate. So this length is given as 200. 200 minus half of this value. This is 6. This is also 6. So 200 minus this length. Y2 is equal to 200 minus 6. That is equal to 194 millimeter. So now you have to apply in this equation, that is x bar is equal to 12 into 200, that is 2400 into x1, that is 6, plus 138 into 12 into x2. x2 is equal to 81 divided by 2400 plus 138 into 12. So this is equal to 36.62 millimeter. So now y coordinate is equal to a1 by 1 plus a2 by 2. So here a1 is equal to 12 into 200 plus a1 into y1. So into y1 is equal to 100. y1 is 100 plus 138 into 12 into y2 is 194 divided by 2400 plus 138 into 12. That is equal to 138.38 millimeter. So this steps are very important. First step is you have to mark the reference axis. So here you have to mark both the reference axis, that is OX and OY axis, because this is an unsymmetric section. Then the next step is you have to write this equation, that is equation based on the figure. And the next step is you have to write the area x coordinates separately. This carries marks, and for the final answer you will get the final mark. So next we will see the centroid of this section. So the first step is you have to draw the reference axis. This is also an unsymmetric section. This is the reference axis OY to calculate x coordinate, and this is the reference axis to calculate y coordinate. This is the OX axis. So first step is you have to draw the reference axis. Then you are having three rectangles. You have to split this figure. So now this is your first rectangle. So now this is your second rectangle, and this is your third rectangle. So this is how we are dividing. This is first rectangle, second one, and this is the third one. And all dimensions are given in centimeter. So now you have to write the equation. X coordinate is equal to a1 x1 plus a2 x2 plus a3 x3. You are having three rectangles. Next a1 plus a2 plus a3, and y coordinate is equal to a1 y1 plus a2 y2 plus a3 y3 divided by a1 plus a2 plus a3. So now the equation is based on the given figure. So now you have to calculate the values of a1, a2 and a3. a1 is equal to 14 into 2, 14 into 2. And now a2 is equal to this length, the total length is 24. You have to deduct this 2 and this 2. So the depth is 20 into width is given as 2. So here it is 40 unit is centimeter square. Here it is 28 centimeter square. So now A3 is equal to, this width is 8, this depth is 2. 8 into 2, that is 16 centimeter square. So now the next step is you have to calculate x1, x2 and x3. So now you have to measure the distance of the centroid from the reference axis to get x1. So this width is equal to 14, that by 2. 14 by 2, that is equal to 7. So x1 is equal to 7, 14 by 2. And this depth, that is y1 is measured from the reference axis OX to the centroid. So this is equal to d by 2. y1 is equal to, total depth is 2. 2 by 2, that is 1, and the unit is centimeter. Similarly x2, so here you have to place the rectangle like this, and this distance is equal to, total width is 2, that by 2. So 2 by 2, that is 1. Then y2 is the centroid of the second rectangle from this reference axis OX. So this length is equal to 2, and this depth is 20. So we have this depth is equal to 20. So 20 by 2 is 10. This length is 10. So from the centroid, this depth is equal to 20 plus 2. So y2 is equal to 20 plus 2, that is 22. So now x3, that is equal to, this total width is 8. Total width is 8. So this length is equal to 8 by 2, that is equal to 4. y3 is measured from the reference axis OX to the centroid of the third rectangle. So this length is 2, this is 20. Then half of this length, that is 1. So 2 plus 20 plus half of this length, this is 2. So this length is equal to 1. So 23 unit is centimeter. So now you have to substitute all the values in this equation. Here you have to make one correction. y2, this length is equal to 2, and half of this length is equal to 10. So this is not 22, this is 12. This is 2, and half of this length is, this is 20 by 2. So this length is equal to 10, and this length is equal to 2. So it is 12. So after substituting all the values in this equation, you will get x coordinate is equal to 3.57 centimeter and y coordinate is equal to 10.43 centimeter. So now we will discuss the centroid of a unsymmetric section. For an unsymmetric section, there is no need to calculate the x coordinate because this figure is symmetric about y axis. So you have to calculate only y coordinate. So y coordinates are usually calculated based on the reference axis OX. That is, this is the reference axis to calculate y coordinate. So this axis is named as OX axis. And now when you take this figure also, this simple figure, that is the first rectangle and the second rectangle is symmetric with respect to this y axis. So the right half and left half of the composite section is also symmetric. Right half of the first rectangle, this is the first rectangle and this is the second rectangle. So simple figures are also symmetric. Then the composite section is also symmetric about the y axis. So there is no need to calculate x coordinate, but you have to write the answer for the x coordinate, otherwise you won't get a mark. So here we can write the equation for x coordinate, that is equal to a1x1 plus a2x2. You are having two simple figures, so this is the equation. And now in this equation, x1 is usually measured with respect to the left line, extreme left line. So x1, based on that extreme left line, it is x1 is 200 by 2, that is 100. Again x2 is also measured with respect to this line. This length is also equal to 200 by 2, that is 100. You can assume all the dimensions in millimeter. So here x1 is 100, x2 is also 100. So now the area of the first rectangle, is 200 into 20, and area of the second rectangle, that is equal to, this length is 300 and this width is 20, 300 into 20. So on substituting these values, you will get x coordinate is equal to 100 mm. So you have to write this value, otherwise you will not get mark for the x coordinate. So here you can write, there is no need to do the calculation. x1 is equal to, x2 is equal to, x bar is equal to 100. For a symmetric section, you can write like this. So for a symmetric section, you have to check whether the composite section and the simple figures are symmetric about the axis. So all the figures are symmetric about y-axis. So you can write x1 is equal to, x2 is equal to, x bar, that is 100. So next step is you have to calculate y coordinate, that you have to calculate using this equation. a1 y1 plus a2 y2 divided by a1 plus a2. So here you have to calculate y1 and y2. So now this is the first rectangle. So centroid is located here. This length is equal to, total depth is 300 and this length is equal to 150. That is half of that value. So y2 is equal to 150 mm. So next, centroid of the first rectangle is here. So this depth is equal to, this is 20. So this depth is equal to 10 and this total length is 300. So y1 is equal to 300 plus 10, that is equal to 310 millimeter. So now you have to substitute the value. You will get a y coordinate as equal to, a1 is given here, a1 is 200 into 20, a2 is equal to 300 into 20, y1 is 310, y2 is 150. So now y bar is equal to 214 mm. So when you are getting a symmetric section like this, that is T section, maybe it is asked as a 3-mark question. There is no need to calculate this x coordinate. You have to write the equation for a1, a2. Then you can write x1 is equal to x2 is equal to x bar, that is equal to 100. Provided you should check whether the simple figure as well as the composite section is symmetric about this axis. Then only you can write like this. So second figure is also symmetric about a y-axis. So here you can see the composite section as well as the simple figures are also symmetric about this y-axis. So here you can assume this as the first rectangle. Now this is the second rectangle. And this is the third rectangle. So here while calculating the y coordinate, you have to take the reference axis. So this is the reference axis to calculate the y coordinate, and this is OX axis. So if it is an unsymmetric section, you have to choose the extreme line, extreme left line, to calculate the x coordinates. So here also we have to write the x coordinate, but you can write it directly. So here you have to measure the x coordinate from this extreme left line. So x1 is the distance from the extreme line, extreme left line to the centroid. So this length is equal to, that is the total width is 150 and this length is equal to 150 by 2. So here also this length is 150 by 2. So here in this figure you can write area A1 is equal to 100 into 20. A2 is equal to 100 into 20. And you can assume the unit as millimeter. So area is millimeter square. And now A3 is equal to 150 into 30 millimeter square. So now you can write x1. So x1 is measured from this reference line. So you can write here x1 is equal to 150. So 150 by 2, that is 75 millimeter. x2 is equal to 150 millimeter. Again you are measuring from this reference line to the centroid of the second rectangle. So it will be here. This length is equal to 150. This is also 150 and this is also 150 by 2. This is also 150 by 2 and this is also 150 by 2. So x2 is equal to 150 by 2. x3 is again this length, that is 150 by 2. So you can write directly x1 is equal to x2 is equal to x3 is equal to x bar is equal to 150 by 2, that is 75 mm. So there is no need to do the calculation. You can write x1 is equal to x2 is equal to x3 is equal to 150 by 2, that is 75 mm. So next step is you have to calculate y1, y2 and y3. For that you have to take this as the reference axis. So you have to measure y1, that is the distance from the centroid of the first rectangle to the x-axis. So this distance, this is equal to 30, this is 100 and this length is equal to half of 20, that is equal to 10. So 130, this is 100 plus 30, 130 plus 10, that is 140. y1 is equal to 140 mm. Next is y2. So centroid of the second rectangle is assumed here. So here this length is 30 and this length is 100. So now this is equal to half of 100, that is 50. So 50 plus 30. So y2 is equal to 80 mm. And now the centroid of the third rectangle, it is assumed here. So this length is equal to this total depth by 2. So y3 is equal to 30 by 2, that is 15 mm. So now you can apply in the equation y bar is equal to a1 y1 plus a2 y2 plus a3 y3 divided by a1 plus a2 plus a3, that is equal to 59.71 millimeter. So here also you have to write the equation for x bar. You don't have to do the calculation. Instead you can write this equation, but you have to include the equation. X bar is equal to a1 x1 plus a2 x2 plus a3 x3 divided by a1 plus a2 plus a3. So this equation carries mark. Usually you have to write the equation based on the question, and all these values you will get mark. So this is how you have to calculate the centroid of a composite section. So we have discussed only composite sections made up of rectangle. So we will discuss composite section made up of triangle, semicircle, circle in the next video. So till then, thank you.